Welcome back, everyone. In the last few lessons, we've really optimized our front-end React code. What we want to do now is actually push this live to Heroku. And by doing so, we'll actually notice that there's something particular about Heroku that makes it so we have to add another optimization. But I'm always a fan of seeing the problem before showing you the solution. So let's see it first. What we're going to do is go back to our terminal and update Heroku with our new code. So what we're going to do is we're going to say git add -a, right? Git commit -m, adding performance optimizations to codebase with React, lazy, suspense, and memo. Now, when you make this push, you might have to reconnect your Heroku project if you've cloned and then used a project from one of the GitHub links that I've sent you. This is important because your project with Heroku is actually not connected to the cloned account. So if that's the case, please check the Heroku deployment video again to see how to link a Heroku project on your CLI to your actual project profile. So with that in mind, I'm just going to actually run it now with git push Heroku master. So this will push my code now and initialize a new build. Now, as you remember, this actually takes some time. So I'm just going to speed through this process until we hit actually a certain portion of the build that is going to be interesting. So now's a good time for us to jump in and actually take a look at this statement right here. So we'll see that what Heroku did here was run our React build script, building our actual project for the final deployed application. You'll see that these chunks are actually the chunks of our application that are being split into where we added our chunking code, which was where we did our lazy loading. What's interesting to note is that this is the initial chunk, which includes all of our libraries and dependencies. The subsequent chunks are the chunks related to the actual applications that we broke into our lazy loaded routes. But you'll see that here it says file sizes after gzip. But what is gzip? Gzip is actually a compression strategy that the backend servers do so that when they pass it through HTTPS from the server to our client, it's in a smaller package where it gets unzipped in the actual client browser. At that point, it will be the full size that the actual project is of each of these bundles. But you'll see that these are the sizes that we should be expecting. 220 kilobytes, 7.24, 7.21, and then really small sizes afterwards. So once this is done, let's reopen our project in our actual Heroku link, and let's see how long it actually took. So let's force a hard refresh, go to our network tab. So here, when we look at the actual chunks, we'll see for some reason they're way, way bigger than what we were told when our build script ran on our Heroku build. We see that the initial chunk that was supposed to be 226 kilobytes is 776 kilobytes. Our main chunk is 27.4 kilobytes when it should have been 7 kilobytes. And then these, which should have been more negligible, 1 kilobyte or 400 bytes even, are still in kilobyte sizes. So why is it that these are bigger? Well, it turns out that the reason for this is because Heroku does not offer gzipping right out the gate. In order for us to do it, we have to manually apply gzipping to our Express server. So this is actually another benefit we have for writing our own backend Express server, which serves our client at any of the routes that we did. It's actually very easy for us to do this, in fact. All we need to do is add in a library that Express maintains themselves to provide gzipping to our node server. So all we have to do here is we simply yarn add compression. The compression library is a library that allows us to compress and gzip all of the files and chunks that we end up sending out from our server. So now what we do in order to use it is inside of our code, we go to our server.js file and we create a new const called compression, which requires compression, the new compression library that we just installed. And then what we do is inside of all this app.use, we're also going to say app use compression. And now if we save, let's just repush this up again. So let's do git add again, git commit, adding compression library for gzipping on Heroku. And then let's git push Heroku master one more time. And again, I'm going to speed through this section because this is going to take the same amount of time as last time. So we've finished our build. We've updated our Heroku. Let's go back to our Heroku account and let's do a hard refresh. And then let's look back at our network tab. And now we'll see that our chunks are definitely the sizes that they should be. So here we'll say our chunk.js is now 222 kilobytes, which matches what the build script was telling us it should be. And we see that our main chunk is 7 kilobytes. So now our code is actually pretty optimized. It should be pretty fast because everything is pretty much the base size that it needs to be on the wire. The only thing might be the images are a little large, but honestly, because we're an e-commerce platform, there are more complicated advanced techniques of optimizing these images. That is not really something that we as React developers need to do. This is generally something that could be done by a designer or somebody that is more familiar with actually optimizing images. But with that in mind, we have optimized our application quite significantly now, and our size and speed should be much faster with our actual final deployed application. So again, it was very easy to just add in gzipping to our Express server for Heroku, simply using the compression library. And with that, we're going to move into one more almost paradigm when it comes to performance, which is progressive web apps. So we'll talk about that in the next lesson.